4.2, implicit differentiation. Implicit differentiation is the process by which we find dy dx or y prime. Starting off strong. Sounds just like everything else we've done, right?
Yes.
So, I'm going to do a quick little example. I don't expect you to understand. I just want you to see where we're going so that you see that I'm not going crazy and calling it a new thing and it's not. If I give you y squared is equal to x and I tell you to differentiate that, this would be 2y, y prime, is equal to 1.
I get the 2y part.
AKA, y prime is equal to 1 over 2y.
I see. I do.
Basically, how do I word this? We're chain ruling y, kind of.
Yeah.
You take the derivative with respect to x, but then you still have the derivative there, basically. This is where the primes really come in, obviously. So, the process, because, gotta love a good process. The implicit differentiation process. First, differentiate both sides. Of the equation with respect to x. Two, get y prime terms on the same side. Three, factor out any y primes. And 4, solve for y prime. So this is kind of back to when we had problems that gave us like x's and y's on both sides and we were trying to solve for y. In a sense, it's going to end up looking like that algebraically, but obviously we've got to do a derivative before we get that far. But that was back early algebra 2 we did that when we were solving for a variable, basically trying to get stuff by itself when it was, multiplied and added and, flipped upside down and all the fun things. So that's all the notes for this section.